Yeah, I want to make 4 points today about scientific information in the context of what was called an infodemic by the World Health Organization. So I want to present some data about the status of science, the public response to it, the misinformation that is being leveled at science, and what we might do in turn in response to that. So, the infodemic. The virus came along, we had a pandemic, according to the World Health Organization. We also had an infodemic of a lot of misinformation and disinformation that was flooding social media. Now, that, I think, is true. But what is also true, and often overlooked or not recognized, is that another consequence of the pandemic in many countries, not everywhere, but in many countries, was that people started to trust scientists more. So, to illustrate that, this is the Wissenschaftsbarometer taken last year, the last data I could find, about trust in scientists in Germany. And what you can see here is that between 2019 and 2020, so right at the onset of the pandemic, there was a striking increase in the percentage of people who trusted scientists, up to 73%, a strong decline of people who were undecided, and basically no effect on the small proportion of people who claim they distrust scientists. And that has persisted. We are now, we collectively as scientists, are trusted more now than we were before the pandemic in Germany. Now in the UK, similar patterns have been observed, although the data are not quite as extensive as they are in Germany, so I only have the occasional snapshot of public opinion in the United Kingdom. There's also good news when you look at people's trust in the COVID-19 vaccine. This is a study that looked at, 25 or so countries, you can count them if you want, with 1,000 participants in each country. Now, the blue bars mean people accept the COVID-19 vaccine as safe. The orange is hesitancy, and if you look at this pattern, it is actually looking okay. Wow, there are exceptions to that, of course. We have South Africa, we have Ghana, where there's a lot of hesitancy, but I think the overall pattern is relatively encouraging. What's also encouraging is, if you look at the last two columns here, which is the change in acceptance between 2020 and 2022, or 21 and 22, and anything blue means that there's an increase in acceptance. Anything orange means a decline. Well, and actually, that's not looking too bad because there's hardly any orange. So, looking good at first glance. But there are two buts, and that is what we can't ignore. The first exception to this generally positive pattern is that the residual vaccine hesitancy, when it comes to COVID-19 specifically, is hardening. What I'm showing you here are the share of unvaccinated people in October 21. That's a relevant date to the extent that by that time, vaccines were widely available, and in theory, everybody could have been vaccinated. And indeed, in Portugal, everybody was vaccinated, well, except for 1.5%. We ignore that. I mean, that's really almost everybody. But now, look at the German-speaking countries, Austria, Switzerland, Germany. Large number of people hadn't been vaccinated. If you then ask these people who haven't been vaccinated whether they will be vaccinated, then about 2/3 say no way. Another quarter roughly says probably not. And only about 10% say, yeah, well, maybe. And by the way, in case you're wondering, of these, about half voted for the extreme right, and another 15% for other establishment parties. None of that is surprising. We know ahead of time what their politics are likely to be. Now, just to be sure, these survey data are, turns out, quite meaningful, because when you go to the actual uptake data about 9 months later, then the additional uptake of the vaccine, the first dose that was administered in those 9 months, very much mirrors the survey data. So that's about 10% of the initially unvaccinated people who then did take it. The others who said they wouldn't, they in fact did not. So that's something we got to worry about. The second thing we got to worry about is the United States. You always have to worry about the US these days. And this is where the pattern has gone the other way. These are Pew survey data just published a few weeks ago, where they traced out people's confidence in scientists to act in the best interest of the public. You have American adults altogether in the left panel, and then you have it broken down by Democrats and Republicans. And when you break it down by politics, you get a fairly striking polarization in the sense that the vast majority of Democrats, even though it's gone down a tiny bit, nonetheless, vast majority of Democrats trust scientists to act in the public interest, either a great deal or a fair amount. With Republicans, the pattern is quite different. We're now down to only about 61% of Republicans believing that overall, whereas 38% think that scientists do not act in the interest of the public. And this polarization in opinion has lethal consequences. Here is a recent study by Wallace and colleagues who looked at excess mortality in 2 states. This is Ohio and Florida, I think. And they compared excess mortality between Republican and Democrat voters. Now, if you go back to before the pandemic, then the excess mortality is 0. Well, yeah, exactly. It's the baseline, right, before the pandemic. So, of course, there is no excess mortality by definition. And also, the 2 parties don't differ. The orange and blue, there's absolutely no difference. Then the pandemic hits, and people start dying, and there is a large number of excess deaths. But again, both parties are nearly equally affected by that. And this panel in the middle is before vaccines were widely available. But now let's look at the last panel, and this is the crucial one. This is excess mortality after vaccines were freely available and everybody could have been vaccinated. And in fact, if you look at the x-axis here, that's the share of the population in a given county in these 2 states that had been vaccinated. And there's quite high uptake for at least some of those counties. But now look at the differences between parties. Now there's a gap, and the gap is up to 10%. 10% more excess deaths among Republicans and Democrats. Why? Because they don't get vaccinated, because that's where the gap is, at the low end of vaccination uptake. In the high vaccination uptake counties, the difference again disappears. But people die because they don't get vaccinated. And one reason they don't, of course, because of this partisan difference, is because they don't trust scientists. And they're susceptible to misinformation. And the misinformation and the distrust that is being disseminated on social media and elsewhere has a trend that we can arguably extrapolate in the future. This study by Johnson et al. From a few years ago measured the number of supporters on Facebook that are anti-vax versus pro-vax. And at the time, there was a majority of people on Facebook who were pro-vaccination, 7 million as opposed to 5. However, they also did an analysis of the dynamics and the evolution of these networks. And based on that, their projection was that, about 10 years from now, it flips over. There'll be more anti-vax than pro-vax. If we do nothing, of course. And just to put some more numbers onto this, a recent study by Sasha Altay and colleagues looked at the infodemic and wanted to quantify that, and their number is that about 14% of engagements on Facebook were with untrustworthy content. The web overall is only 2.3%. Well, yeah, but that includes the Amazon and, airlines and things, so that's not such a good number. So we have a problem, notwithstanding the fact that in Germany, at least other European countries, scientists are being trusted by the public. So we need to talk about trustworthiness and trust. Now, before we can ask for trust, we have to be trustworthy. How can science be trustworthy? Well, there's been a lot of talk about this during the last 2 days here in this room. But of course, there's a lot of other discussion going on, and people very often come up with transparency and openness. Materials and procedures must be reported so that we can replicate each other. Indeed, and data should be available for everyone to reproduce the analysis. Now, we probably all agree with that. I certainly raise my hand and agree with that. But I agree with it with caveats, because there's two things we got to be concerned about. Transparency and openness can be abused. And ironically, and this is a point that's really underappreciated, for openness to enhance trustworthiness means that people have to trust us to begin with. You cannot have trustworthiness based on openness without people trusting us. I'll explain in a moment why I'm saying that. I want to focus on these two exceptions, or limiting conditions, as I call them, for transparency and openness. I said transparency and openness can be abused. Well, it is abused all the time in broad daylight by industry and lobbyists who are trying to get Congress to pass legislation in the United States. So, for example, the US Data Access Act, there was two, one in 98 and 2000, was drafted by the tobacco industry. The implementation was overseen by the tobacco industry. When I say that, I base it on peer-reviewed science, Baba et al. Journal of American Journal of Public Health. Why? Well, because once you have the data, you can reanalyze it. And then if you're the tobacco industry, tobacco morbidity mysteriously disappears. You just do this competing analysis, and we have to exclude that person because they fell out of their pram when they were 3 years old. That's why they got lung cancer. So that happens all the time. There was a recent proposal that science has to be based on replicable findings in order to inform policy. That was before Congress, during the Trump administration. That failed at the time, fortunately, because what it means to put science only onto replicable findings is that things like the Deepwater Horizon or Exxon Valdez cannot be scientifically analyzed in support of policy, because you can't replicate it. You can't blow up another oil rig to replicate the findings. So there's a Trojan horse out there, a political Trojan horse, that we have to be very careful about. The other thing that I want to underscore is that trust is a precondition for openness to make a difference. Without trust, sharing data is useless. If I send a climate contrarian data, they will just get back to me and say, where's the paper copy where you recorded the temperature? There was a big affair about 15 years ago when in the United Kingdom, the Met Office threw out some paper records from 1890 because they were out of space in their basement after they digitized it. Climate deniers went crazy because, well, you destroyed the evidence. So being open achieves nothing unless the people are trusting you. Because if they don't trust you, then if you send them the data, that's going to be insufficient. They want your emails. They want your browsing history. Not kidding about that. I've been asked for my browsing history by climate contrarians. So, by ourselves, being open and transparent is important, but it's not going to make a full difference. Now, here's another way in which science has to be trustworthy, and that is to be honest about uncertainty. Some scientific findings are established beyond doubt, but others are more uncertain. Now, it turns out the public is actually gratifyingly well calibrated to this. For example, people have more faith in climate projections or weather forecasts if they're accompanied by error bars. They like it. They say, oh, right, yeah, okay, I trust it more than if you give a point estimate. And Michael Bang-Petersen in Denmark has done fantastic work where they looked at the effects of public health communications in Denmark during the pandemic, specifically surrounding the side effects of the 2021, and the vaccine was suspended for some time. And what Petersen showed is that people in Denmark lost trust in AZ, in the AstraZeneca vaccine, but they had an increased trust in the health authorities who were honestly communicating the uncertainty. And this is EU-wide. What I'm showing you here are YouGov data from 2021. The important thing I want to draw your attention to are the red lines for different countries that are for AstraZeneca and show a rapid decline in trust in that vaccine as the side effects emerge. That's the gray vertical bar. But no such thing happened for the other vaccines. So the public is able to differentiate between, specific things that are problematic, other things that are reliable. So, can we conclude that if only science were trustworthy, then everything is fine? No. That is insufficient. And it's so important, I'll say it again. No, it's not sufficient on our own to strive to be trustworthy. Because the moment science becomes politically relevant, it also becomes a political target. And the moment you're a political target, it doesn't matter how trustworthy, transparent, and communicative you are, because then other rules apply that have nothing to do with science. Now, let me tell you a little bit about that, because that actually turns out to be one of my research areas. One of the things we have to realize is sort of obvious, but it's easy to forget. Misinformation doesn't just spread on its own, right? It's not like a kind of a virus that just does its own thing. It's people who disseminate and spread misinformation about anything, vaccines, anti-science, whatever it is. It's people. Now, sometimes they do that inadvertently. They just retweet something from their grandmother or share something on Facebook with their cousins. Of course, that happens. But sometimes it is intentional, and we have to understand when it is intentional and how that intentional spread of disinformation happens. Here's a recent paper where I talk about this and link it to the underlying ideology, which I'll tell you about in a moment. But what is really important to realize is that everything we experience today, let's say in the context of COVID-19 vaccines, is precisely the same playbook that was deployed against medical research about tobacco and against climate science since the 1980s. And Climate denial is going to be ongoing until there are alligators in Alaska, and they'll still keep going. Just go on forever. And interestingly, or distressingly perhaps, it's the same people who are involved in disseminating the disinformation. This isn't a random face, by the way. It's the same people who spread disinformation, this being one of the creatures involved in that. And it's also the same think tanks that are disseminating misinformation. This particular one is interesting because not only was this responsible for a lot of climate denial, they're also the ones who funded the Great Barrington Declaration, which you may or may not remember, early on during COVID, that the WHO described as being simply unethical because their claim was we should deal with the pandemic without lockdowns. Now where does this come from? What explains this disinformation? Why would anybody spread this disinformation? Well, the answer is it's a libertarian ideology. And it's entirely rational for them to engage in this disinformation campaign because if you trust the science on climate change, tobacco, COVID-19, then trusting the science and acting on it has implications for business as usual. You cannot continue with business as usual if you have an airborne virus that requires social distancing. If you have climate change, you have to cut fossil fuel emissions. All of this requires interference with free markets by regulation, law, putting a price on COVID, whatever it is. And any such interference in free markets is considered to be an existential threat to libertarian ideologues and their think tanks. So they respond. And one of the ways in which they respond is to spread disinformation. And as a consequence of that, in turn, the public may become polarized as a consequence. And we know it's a consequence because it wasn't that long ago that there was a bipartisan agreement in the United States to deal with climate change. Republicans were on board. But then the Republican leadership withdrew from the issue, and it was only because of the leadership withdrawal that the public then became polarized. There's work by sociologist Robert Brully that shows that causal relationship. And once the public is polarized, wow, you get massive effects. This is synthetic data illustrating the strength of the effect. I know you probably all know what a correlation of minus 0.7 looks like, but I still want to show you because it's kind of like, wow. And this is the correlation between endorsement of free markets and people's attitude towards climate science. And basically what it shows is that the more you love free markets, the more likely you are to deny climate change. And it doesn't matter how you measure worldview, whether you look at free markets, look at party identification, conservatism, all these other fancy psychological constructs. It doesn't, you know, the effect is so strong. It doesn't matter how you measure it. It's also global, not as strong in other countries as it is in the United States and Australia, but it is there. And this now raises an interesting question. Why libertarianism and conservatism, other than what I've already said, which is that science can be threatening to their worldview? Is there something else? Is there something that predisposes conservatives to reject scientific evidence? What is it about science that makes people, some people, want to reject it? And just to be perfectly clear, when I talk about a predisposition here, I'm talking about a statistical phenomenon. That's not to say every conservative is a science denier. No, not at all. Margaret Thatcher was not a climate denier. She had a bachelor's degree in chemistry. She was smart enough to know this is real. And Angela Merkel was a PhD in quantum chemistry. So she also knew what was going on. Ditto with the pandemic. They were both conservatives. But statistically, there is this association between science denial and conservatism. So why? Well, here's some work I've done recently, which, interestingly, somebody mentioned yesterday, I think, somebody said they were insults to people. Science has insulted us. Well, yes, it has, because in the Middle Ages, we were the crown of creation at the center of the universe, according to the church, and that's all that mattered at the time. Big cathedral, we were in it, we were at the center of the universe. God loves us. And now, we're just some species of mammals orbiting a minor star in an extremely average galaxy. Nothing more. Now that can challenge people. It is a challenging thought for some, especially if you're religious, some religions. So it is not surprising on that basis alone that science has done stuff. That's kind of scary, you know, because we're all of a sudden so much less significant than we thought we were. But that's just the beginning. There's more to it. What are the norms of science? This goes back to Merton, a sociologist in 1942, but according to recent surveys of scientists, those norms are still embodied in science today by scientists. So what are those norms? Disinterestedness. Research is for the benefit of science rather than personal gain. The Leopoldina prides itself in independence. We don't take money from corporations. We don't have governments tell us what to do. We are just purely doing science. And the results of our research are the common property of all scientists, something that Merton calls communism. Now, that already tells you something. If there's something called communism, that's a red flag. But he called it that. Universalism. Knowledge transcends nations, political boundaries. We only crossed out in pencil, the names of Albert Einstein and his Jewish colleagues during the Nazis here in the Leopoldina, because we internalized that norm of science. And now just have a look and try to reconcile the norms of science with conservative values. Well, it's kind of hard, I think. Not impossible, of course, but at first glance, I would argue that there's potentially a deep conflict between the norms of science, if you take them seriously, and the values of conservatism. Certainly the American brand of conservatism, which deals a lot with property and profit rights, and it's culturally probably very different than other countries. Why am I mentioning this? Well, I'm mentioning it because Klaus Oberauer and I published 2 studies on this recently, where we tried to relate potential predictors of acceptance of science. For science, we plugged in climate science and vaccinations because they're both hotly contested. And in the one study I want to focus on, we measured conservatism, social dominance, which is sort of a branch of conservatism, and we directly tackled the norms of science. And here are the data. Let me walk you through it. Lots of numbers here. You don't have to absorb them all. I'll walk you through it step by step. Step 1, both indicators of conservatism were negatively correlated with acceptance of climate change, as you would expect. There's nothing surprising here. Also negatively correlated with vaccination acceptance. That's also not surprising because, contrary to much speculation in the media, vaccine hesitancy also focuses on the political right, not the left. Simply incorrect to say that vaccine hesitancy is the domain of the left. It's not, statistically. So that's good. We replicate a known finding. We also show that acceptance of climate change and vaccinations is highly associated with acceptance of the norms of science. The projector isn't all that great. You can't see the writing. And conversely, acceptance, this is the main point, of the norms of science is negatively correlated with conservatism and social dominance, which is sort of the cousin of conservatism. So that was our point, to show that the norms of science have a tension with conservatism. And that may be the underlying explanatory construct to explain why conservatives are so much more likely to reject scientific findings than people on the left. And it also explains why I have not been able to find left-wing science denial, if you want to call it that, much in like 10 years. I've been chasing this for 10 years, literally, because I wanted to show that, you know, people on the left can be as anti-scientific in their public attitudes as people on the right. Well, I haven't been able to show that. Certainly not with American samples. Even with nuclear power, turns out Democrats trust scientists more than Republicans do. Anyway, here we are. We do have this conflict, and we have to deal with everything that arises. And that's the last point, last segment I want to turn to today, which is now what do we do? Okay. Well, I would suggest, and there's multiple answers, lots of different answers. I will focus on 2 or 3, depending on how I go with time. Now, they all, certainly the first 2, rely on analyzing misinformation. What do I mean by that? This issue has come up repeatedly yesterday and today. How do we know what's pseudoscience and what's science? Sometimes the pseudoscientists sound like scientists. In fact, they all claim to be scientists. You know, I invented the mRNA vaccine. That's why I know how it's going to kill you. Okay, it's a very common thing for pseudoscientists to claim scientific credit. So, how can we tell? Well, here is one way in which we can tell, known as FLIC, which are markers of anti-scientific misinformation that have been identified by people working on this area, myself included. Fake experts, you know, the tobacco industry used to roll out hundreds of people in white lab coats saying, oh, I smoke whatever because it's good for me, all right? Except they weren't really doctors most of the time. Logical fallacies, impossible expectations, cherry picking, conspiracy theories. Conspiracy theories, of course, abound. You scratch the surface of climate denial or vaccine hesitancy. It's almost inevitable that beneath the surface there will be some form of conspiracy theory. Now, I can't go through them all to illustrate, so I figure cherry picking is a good one to illustrate because it's everywhere, and it is one of the clearest markers of pseudoscience or science denial. Now, here's something that is originated on a so-called TV station in Great Britain, calls itself Great Britain News, funded by people in Dubai, I think, some Middle Eastern money. And the claim is that the country with the lowest vaccination rate has the lowest excess mortality rate, and the country with the highest vaccination rate has the highest excess mortality. This was reported just over a year ago. In other words, the vaccines are killing you. Don't get vaccinated. How did they do this? Well, they did it by comparing Portugal, which has the highest or second highest vaccination rate in Europe, to Bulgaria, which has the lowest. And they very carefully chose a month, just a single month, to compare excess mortality, at which time there was a heat wave in Portugal that was so intense that it was killing enough people to raise their excess mortality over that of Bulgaria. Bulgaria did not have that heat wave. Overall, there is, of course, no such association. On the contrary, the association goes the other way. This will repeat itself, so I don't have to talk fast. What you see here is vaccine coverage from 0 to, well, whatever, a large number. That means, you know, more people get vaccinated. And this is the excess death rate over time. And what you can see is that everything starts out over here, a high excess death rate. Come on, restart. It'll restart in one. Yep, there we go, January 21, right? Vaccines become available, lots of extra, lots of extra deaths. And then as vaccines are being introduced, it goes back to baseline. So that's what really happens with vaccines. But of course, you can cherry pick your way out of that. And it's not just anti-scientific misinformation, it's misinformation generally that has markers, and we can exploit that through a technique known as inoculation. Inoculation is a cognitive equivalent to vaccination. It is creating what we call, sometimes jokingly, cognitive antibodies by warning people how they might be misled and then boosting their ability to detect it. Now, published a paper last year in Science where we looked at that for a lot of different rhetorical techniques, including one with about 22,000 participants on YouTube, so in the real world, and we show that people become better at discerning between high and low quality information. And if this works, I'm going to play one of the videos for you. And can you have the, yeah. Sound? No sound. That's not so good. It's HDMI. Oh.
Looks like the trick works. You see, when watching videos or browsing online, you're likely to encounter content that is loaded with emotional language. And with the research, playing into emotions, especially negative ones such as fear, anger, or contempt, is a trick to get you to pay attention to something you otherwise wouldn't. It's likely that a big part of the reason you're still watching this now is because you were lured in by using emotional language in a very bad sentence. Research has shown that expressing emotion is key to the spread of moral, and especially ideas in social networks. So let's say when you're writing a headline and you're trying your hardest to manipulate your reader's play. One thing you can do is to heft your headline with a bunch of emotionally charged words. Call it a horrific accident instead of a serious one, a disgusting ruling instead of a disagreeable one, or a heartbreaking twist of fate instead of an unfortunate coincidence. That way, you're likely to reach more people and influence their reactions. So let's see how this plays out in real life. Let's take the following headline from the movie Hangover. No emotional manipulation of flavor, just to the point, no nonsense coverage is such an important event in world history. This headline, on the other hand, see what they did there? The writer used an emotionally charged word like revolting to describe a whole group of people. I mean, you get the point. They're fear-mongering. So whenever you feel outraged or angry, remember, someone will be feeling strengths. Don't be truth matters. The whole truth and nothing but the truth.
Okay, so that gives you an idea of inoculation. Do we know it works? Well, yeah, I just told you about the experiments that we published last year in Science, but it also works in the field. This is a recent study done by Google in Eastern Europe, where they showed videos of a similar nature to people in Poland, Czechia, and Slovakia to inoculate them against misinformation about Ukrainian refugees. And by and large, that worked. And in case you're interested in finding out more about how you can deal with misinformation and how you can deal with conspiracies, here are two public-facing documents that my colleagues and I have produced and that are available in 20 and 18 different languages, respectively. Thanks to the efforts of a lot of volunteers who come out of the woodworks and want to translate this. I'll have a QR code at the very end with a resource, a pointer to resources so you don't have to write them down. Now the final thing I want to focus on in a couple of minutes is, all right, we so far dealt with misinformation and how to tackle that. But that's not all we can do, nor is it what we should do. We should also speak for science and about science. And how do we do that in a way that is persuasive for the public and effective? Well, one such technique that I've been working on is to underscore the scientific consensus when it exists. There was some mention of this issue earlier today. Oh, organized skepticism means we always disagree with each other. Well, only until something is settled. And then we move on, and that becomes consensual science. And that is how science works, very often unbeknownst to scientists. If you ask scientists about this, they say, oh, no, there's no consensus. But then you ask them something that's fundamental to their field, and they all agree, like evolution in biology. Nothing makes sense in biology without evolution. Well, that's a consensus, even if you don't know it or like it. So how does this work? Just to illustrate, well, imagine you like oysters, you're in New Orleans or somewhere where they sell oysters. You're tempted to eat this for an outrageous amount of money, but then you find out that 97 out of 100 microbiologists say, oops, these are contaminated, they might kill you. There's two that are unsure, and one says, oh, they're safe. Would you eat those oysters? Well, you make your own choices, but I think it's very clear what all of us would do for very good reason. There's a lot of philosophy underlying this about why a consensus can be trusted under certain circumstances. Now, we have a consensus about climate change, for example. And the number 97 I had with the oysters was not coincidental, because based on a large number of papers, the scientific consensus on climate change encompasses about 97% of the community and 97% of the literature. Now, communicating that consensus increases acceptance of the science, and occasionally, I mean gratifyingly often, let's put it that way, it also enhances acceptance of the science among conservatives who we know from before are predisposed towards not accepting global warming. Here are some data of my own from a long time ago. I started this consensus research, much of it, where in the control group, the more people believe in free markets, the less they believe in climate change. But after we provide them with consensus information, there's a significant increase and a significant interaction, and that's been replicated many times. This last study I want to tell you about is particularly amazing. This was done in the field in the Czech Republic and dealt with using consensus messaging to enhance the uptake of the COVID-19 vaccine. So for starters, the researchers surveyed 10,000 doctors in the Czech Republic, and it turns out 90% of them trust the vaccines and want to get vaccinated. This was right at the beginning of the rollout. Now, the public thought, as they often do, that only 50% of doctors would trust the vaccines. This gap between scientific consensus, actual consensus, and public opinion is pervasive, and it is due to the media offering this false balance, pairing a scientist with a pseudoscientist very often, then having a debate about climate change. The researchers then did a controlled experiment, 2,000 participants, assigning them to a control or to a consensus intervention, and they then measured uptake over time. And the intervention consisted of truthfully reporting using multiple slides to those patients, I guess, members of the public, the consensus among Czech doctors. This is translated into English, but the original obviously was in Czech. And what did they find? They found that over time, the people who were treated by the consensus message had a significantly higher vaccine uptake. There's a lot of different ways in which they did the statistics. Lots of error bars here, but the point is that the more you go to the right, the more time they had afterwards, the more vaccines were available, the greater the effect on vaccine uptake. So this moved the needle in reality and actually probably saved lives or at least hospitalizations for the people in the treatment group. And because the consensus is so important, there's another handbook, public-facing document my colleagues and I produced. Let me conclude by letting you go wild on that if you want, which points to a whole page full of resources dealing with communication, disinformation, misinformation, and a couple other things I've worked on. So thank you very much for listening.